one last thing I want to do with this example is show how we can use the compare to method that we wrote in our student class to do things like sort the roster in the course class. Okay, so let's go into our tester class and let's create a course. I'm going to comment out some of the stuff we did before with the equals. Okay, so let's create a course. Okay, what do we need to send in there? We need to send in our max enrollment, of course. Okay, and then let's go ahead and enroll some students. So we will enroll student S1, enroll student S2, and enroll student S3. Okay, so we'll enroll some students, and now let's print the roster. So when we do that, we'll see that we get them printed in the order that we added them. Once my Eclipse unfreezes. Okay. Okay, so our roster prints with Sally Studier, Pete Procrastinator, and then Ellen Asks a Lot, because that's the order that we added them. And you'll also notice that it's the two-string version of the student class that gets printed, right? Because here in the print roster, we get a student off our array list in the ith position, and then we invoke s.toString. So it's that toString method that we invoked inside of the student, that we wrote rather inside of the student class, that gets invoked here. Okay. Now, let's say we wanted this list to be sorted when the roster was printed. Well, because we've defined compare to in our student class, because our student class implements comparable, what we can do is we can use the Java provided sorting methods. Now, later in this course, we're going to talk about specific sorting methods, how to sort things, different algorithms. For now, it's enough to just use the ones provided by Java and be confident that sorting is something we're definitely going to cover a little later on. But for now, there's two sorting methods that we can use. There's collections.sort, and that allows us to sort things like array lists and linked lists. And then there's arrays.sort, capital A arrays.sort, which allows us to sort, not surprisingly, arrays. So because this is an array list, I'm going to use collections.sort, and I'm going to sort my students. Now, collections.sort as well as arrays.sort, what it does is behind the scenes, it invokes the compare to method of whatever class is being held in that array. So for this line here, collections is going to invoke the compare to method of the student class. Okay, if my array list held integers, then collections.sort would invoke the compare to method of the integer class. So whatever class you put into that collection, into that array list, that's the compare to method that will be used. Now, this only works if our class implements comparable. So let's say it didn't. Let's go back to this version before we implemented comparable. Let's just comment that right out. Just comment this out right here. Okay, so now this is our class before we implemented comparable. We now get a compiler error on this line because the collections.sort method says, I can't sort students. I don't know how to compare students to each other. I don't know the natural ordering. So the only way that you can use these really nice sorting methods that Java gives us is if your class, underlying class, implements comparable. Okay, so that's why we do that. That's why we implement comparable. So that if we want to do something like sorting a group of objects, we can now do that. And later on, when we do learn how to write our own sorting algorithms, I think you'll really appreciate how simple it is to invoke Java's provided sorting algorithms rather than writing our own. Okay, so again, having that class implement comparable and thus have that compare to method is what allows us to invoke this nice simple sorting method. So now that we sort inside the roster, if I go back to my tester program and run this, you'll see that the students are now sorted by last name, Ask a Lot, then Procrastinator, then Studier. Okay. Now, what if I had a different ordering of students? What if I had said, well, I don't actually want my students ordered by name. Let's write a different version where they're ordered by ID. Okay. So here I'm going to write a new, I'm just going to comment out the old version, and I'm going to write a new version of compare to, and I'm going to order by ID. Now, I can't do this. Just like I did for names, I can't do this for ID. Why not? Well, I can't do this for ID because student ID is an int, and you can't invoke any methods on an int. So there is no way to invoke compare to or any method equals nothing. There are no you can't invoke methods on primitive variables. So I can't do this. So I actually have two options if my compare to method involves a primitive value, a primitive type variable that I want to compare, one option is to just use the good old arithmetic operator. So I could say, okay, well, if my current student ID is less than the other student ID, then I'm going to return some negative number. And again, the negative number doesn't matter. It doesn't matter if it's -1 or -100 or -14. I mean, it really doesn't matter. All that matters is that it's negative, and that means the current object is less than the other object. Okay? And then we can say, okay, otherwise, if the student ID is greater than the other student ID, I'm going to return a positive number. Again, it might not be, it doesn't have to be 1, it can be any positive number. And otherwise, meaning the two integers are equal, this would actually be a good place again to use an assert. There's some notes this week about asserts. If you've never seen this syntax before of asserts, you can take a look at those. This isn't something that's required for this class, but I do include some notes on them in this week because they're used in the textbook quite a lot. But you're also perfectly safe just leaving this out. Again, it's not something that's required for this class, but this would actually, for those of you who want to learn a little bit more about that, this is a good use of insertions because it's using an assert statement inside of a conditional. So I'm asserting something that I already assume to be true. But for our purposes, again, you're not required to know about assert, so I could also just put a comment here, the IDs are equal, and then I will return 0. Okay. So this is one way to implement compare to when the variable that you're looking at, the instance data variable, is a primitive. The other way is that Java gives us a nice method, static method in the integer class called compare. And it does just that. It compares two integers. So I can compare my student ID to my other .student ID. And there's a similar method in double and in the other wrapper classes as well. So either one of these approaches are valid approaches for implementing a compare to method when you want to use primitives. You can either directly compare them using arithmetic operators, or you can use this sort of nice compact way of saying, hey, the integer class knows how to compare two integers. Let's just take whatever it says is the comparison. Okay. So here's a new version of my compare to method. Let's now go back to my tester program and run it again. And now you'll see that now the list is sorted by ID. 1, 2, 3, 4, followed by 3, 6, 7, 1, followed by 5, 2, 6, 4. Okay, so the really nice thing about this use of comparable is that the course class, which sorts the array list of students, has no idea how student objects are ordered. It doesn't know if they're ordered by ID or by name. It has no idea, and it doesn't need to know. The way that students are ordered, their natural ordering, is defined in the student class. Because again, we in general have each class be in charge of its own information and its own functionality. So the functionality of how to order two students belongs in the student class. So that's where we put that information. And then the course class can use that by sorting the list. The sort method invokes the compare to method behind the scenes, and that's how we get our ordering. Okay, so there's an example of using compare to and sorting some objects. Now, as a one last note, students are often confused about like where the compare to is happening. It's very rare that you ever actually invoke compare to on your own class. So, I mean, I could, right? I could say int the comparison number s gets s1 dot compare to s2. So sure, I could do that. I could find out if that number is negative or positive or 0, but why, right? It's very rare that I want to do that. So we write this compare to method not so that we can invoke it. It's pretty rare that we actually invoke it, but we write it more so that we can invoke things like sorting methods, which behind the scenes rely on having that natural ordering there in order to function properly. Okay. So that's again an example of using the compare to method and the comparable interface in order to sort a collection of objects.